All right, this number 5 here was the problem on the 2014 free response. It was problem number 6. And you're being asked to work with this differential equation and do 3 different parts to it. So the first thing was to find the slope of the line tangent to the graph at the point 1, 2. So all we need to do is plug 1 in for x and 2 in for y. We get the dy dx at the point 1, 2 to be 1 minus 2 over 1 squared times 2 minus 1. This is 1 minus 2, which is negative 1, times 1, which gives you negative 1. If you have negative 1, give yourself a point, because that's what they did back in 2014. Part B says, on this axis, can you give the slope field through these 9 points? And so we just have to be careful. Now, one thing we'll notice is that according to our differential equation, whenever we put 1 in for y, we're going to get 0. So on the slope field, anywhere y equals 1, we should have a 0 mark. And so if you had that, the AP would have given you a point for having your zeros in the right spot. Okay. Everywhere else, you just have to be kind of cautious. You have to come back to the differential equation and make sure it matches up with your slope. So we just did 1, 2. At 1, 2, the slope was negative 1. So we're going to make something that's about negative 1 there. If I put 2, 2 in, I'm going to get 1 minus 1/2. So I get a positive times a positive. So I should have a positive slope going through there. Again, the AP doesn't get too crazy about how positive it needs to be, just as long as you have positive where it needs to be and negative where it needs to be. If I come down here to 0, if I put 2 in for x, I get 1/2. If I put 0 in for y, I get a negative. So I'm going to get a negative slope there. So I'll put a negative slope on that. If I put 1, 0 in, I get 1 minus 2. So that's a negative times a negative. So now I'm going to be back to a positive here. And if I put negative 1, 0 in, I get the exact same slope for that. So that should have been positive. And then the last one is this one. If I put negative 1 in there, I get a negative. If I put 2 in here, I get a positive. So this should be a negative slope. Okay. So I should have negative slopes here, here, and here. Positive slopes here, here, and here. If your positives and negatives were correct, give yourself another point. Okay. So then that brings us to finding the particular solution through here. And this is what we've been working on quite a bit the last day or two. We want to bring the dx over and divide by the y minus 1. So you should have dy over y minus 1 equals 1 minus 2 over x squared times dx. If you separated that correctly, give yourself a point. Okay. Then we're going to integrate. So the integral of dy over y minus 1 equals, and I'm going to go ahead and rewrite this as 2x to the negative 2, so I can do the power rule on that in a second. This right here should go to natural log of y minus 1, because the derivative of y minus 1 is dy, so it goes right to there. And then over here, the integral of 1 is x, and then this is going to go x to the negative 1 over negative 1, so that negative 1 and this negative can make this a positive, and it'll be 2x to the negative 1, which really is the same as 2 over x. And I'm going to write it like that so that it's a little easier to find out what c is. Now, back in 2014, they gave you a point for this integral, and they gave you a point for this integral, and they gave you a point for putting plus c. Now, that's very generous. They don't do that anymore, but back in 2014, that's how they gave points away like that. So now today, probably you'd get a separate point here, but the c is going to be a point for putting it down and figuring out what it equals. So let's go ahead and do that part now. We're going to take the 1, put it in for x, put the 2 in for y. So if we put 2 in for y, it's natural log of 1, which is 0, equals 1 plus 2 over 1, which is 2, plus c. We end up with c equal to negative 3. Again, they gave you a whole nother point for that back in 2014. Today, they would just make both of these 1 point. Okay, So we're going to put that -3 back in for c, and then we'll figure out what y equals. So the natural log of y minus 1 is equal to x plus 2 over x minus 3. We'll raise it to the power of e. So y minus 1 equals e to the x plus 2 over x minus 3. We have to decide if this is positive or negative. So the best way to do that is to put our point back in. So if we come back and put 1, 2 back into here, 1 plus 2 minus 3 is 0. So I get e to the 0, which is 1. That's what I want. If I add 1 to that, that gives me 2, and that's what I want the y to be. So I don't want the negative version of this. I want just the positive version. Last thing to do is add 1. Let's throw that right in front. And there's our final answer. And if you had that, you got an additional point. So again, 1 point for the separation, 1 point for this integration, 1 point for this integration. Back then they gave you 1 for this c and 1 for this. Probably today just 1 total. And then 1 point for being able to solve all the way down for y.